Arrangements involving cases. Some problems have more than one case. We're going to calculate the number of arrangements for each case and then add up the value of all cases to obtain the total. The key words in those questions could be at least, at most, or either. So we're going to calculate the number of arrangements for each case, add up those values to find the total. Example 8. Determine the number of arrangements of 4 girls and 3 boys in a row of 7 seats if the ends of the rows must either be both female or both male. So the key word here is either. We are going to take each of those cases individually to find the number of ways to have a female at the end of each row of the seat. And then we're going to look at the number of cases where there's a boy at the end of each seat. First of all, cases of females. So we have 7 seats. 1, 2, 3, 4, 5, 6, 7. We want a female at the end of each row. And there are 4 females that we can choose from. So there are 4 choices that we can place one female in at the beginning of the row. Once that one female is seated, that means there are now 3 remaining females that we can choose from to put at the end. We then fill the remaining chairs. We have 7 people in total. 2 of them have already been seated. So now there are 5 remaining people to be seated. And the number of ways to do that is 5 factorial, because there are 5 choices to sit the first person. Once that person is seated, there are then 4 people remaining that we can choose from for the next position, and so on. And we're going to multiply all of those cases, or not, all of those together. And when we do so, we end up with 1440. We've kind of considered this case using fundamental counting principle, using our permutation notation. We can also write this as I have 4 females and I only want to pick 2 of them to place in the first and at the end of the row. And then we multiply that by the remaining 5 people, placing or sitting all 5 remaining people. In either case, we get 1440. We're going to move our attention now to the second case, where there is a male at the end of each row. We still have 7 seats. 1, 2, 3, 4, 5, 6, 7. We want a male at the front, and we want a male at the end. This time there are 3 males that we can choose from. So there are 3 choices to sit a male in the first seat. Once that male is seated, there are then 2 remaining males that we can choose to place at the end. And same reasoning, there are 5 people, combination of 4 females and 1 remaining male to be seated, 5 people in total. And there are 5, 4, 3, 2, 1 ways to sit that, or the rest of those people. Multiplying all of those, again, that is 5 factorial. So we have 3 times 5 factorial times 2. And in this case, we end up with 720. Again, we could use permutation notation. There are 3 people, and we're picking 2, multiplied by the remaining 5, sitting all 5 people. And again, in either case, we have 720. We have approached this question by taking each individual case and finding the number of ways to do so. We now want to find the total number of ways And to finish up this problem, all we are going to do is we are going to take case 1, where we have females at the end of each row, and we need, oh, I'm sorry, let's change that. It's not and. We can either have a female at the end of each row, or we can have case 2, where there is a male at the end of each row. There are 1,440 ways to arrange the number of, or to find the number of ways to sit those people where there is a female at the end of each row. There's 720. This case where we have or, we are going to add those cases together, and that gives us a total of 2,160 ways to either have female at each end of the row or a male at the end of the row.